Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up the previous lectures continuation on permutations and combinations. It's a very good lecture which you might have seen already my previous lecture on this. To find n, R1 and R2 and R3 such that NCR1 plus NCR2 is equal to NCR3. It's a very good example of a permutations and combinations equation. It's an equation. We do not know what is the value of n, what is the value of R1 and R2 and what is the value of R3. We have to find. This is the only condition given. NCR1 plus NCR2 is equal to NCR3. And here in the last class we have found the solution. Now in this class we will extend that solution to find number of values of n when n is 100 which satisfies this equation and corresponding values of R1 and R2 and R3 if n is less than or equal to 100. For general solution, for understanding the concept of solving this, you please refer to my earlier lecture on permutations and combinations. Combinatorics. This is the topic. On this, we are taking an equation of permutations and combinations and we are finding the value of n, R1 and R2 and R3 such that NCR1 plus NCR2 is equal to NCR3, where n is less than or equal to 100. Let's proceed. What are the conditions given? N is less than or equal to 100. And another condition is NCR1 plus NCR2 is equal to NCR3. It's a very good example. Please pay attention to it. We will go for the solution. Lucas function or theorem. Lucas theorem I have already explained in the previous class. As per that, if n satisfies n equivalent to 2 mod 3, then we can go for some solution in this. And what are the values of n such that it satisfies this equation NCR1 plus NCR2 is equal to NCR3 and also Lucas theorem n equivalent to 2 mod 3. So that above equation, main equation is satisfied. Let's go for their values. N equivalent to 2 mod 3 is satisfied by what values of n? N is equal to 2. What are the values? The above n equivalent to 2 mod 3, what is the meaning of it? N minus 2 is divided by 3. N minus 2 is when n is equal to 2. N minus 2 is 0. 0 is divided by 3. Yes, 0 by 3 is equal to 0. Now what are other values? N is equal to 2. N is equal to 5. Then n is equal to 8. N is equal to 11. n is equal to 14, n is equal to 17, n is equal to 20, n is equal to 23, like that up to n is equal to 98. It's an arithmetical progression. D is equal to 3, A is equal to 2, arithmetic progression. Which you may be are aware. You are aware of this arithmetic progression. For some values. Now let's generalize this. For all the values of this n equivalent to 2 mod 3, whether this particular equation NCR1 plus NCR2 is equal to NCR3 is satisfied. If it is satisfied, what will be the values of R1, R2 and R3, which I have explained clearly in the previous lecture. Let us take n is equal to 2. What happens? Let us see. When n is equal to 2, first case, R1 can be 0 and 2. R2 can be 2 and 0. R3 can be 1 and 1. But here in the previous example, we have put a condition that R1 is not equal to R2 is not equal to R3. R1 is 0, R2 in the first combination R1 is 0, R2 is 2, R3 is 1. So that R1 is not equal to R2 is not equal to R3. This condition is fulfilled. Next, what is NCR1 plus NCR2? That is equal to, n is 2, 2C, R1 is 0 for first combination, 2C, R2 is 2, that is equal to factorial 2 by factorial 2 minus 0 into factorial 0 plus factorial 2 by factorial 2 minus 2 and factorial 0. Factorial 2 by NCR2, 2C2, 2 minus 2, that is 0. It is not factorial 0, it is factorial 2. Now, what is its value? Factorial 2 by factorial 2 is 1, factorial 0 is equal to 1, 1 plus factorial 2 by factorial 0 factorial 2, that is also 1, that is equal to 2. What is NCR3? 2C, R3 value I have taken it as 1. Then factorial 2 by factorial 1 into factorial 2 minus 1. That is equal to factorial 2 by factorial 1 into factorial 1. That is equal to 2. That means NCR1 plus NCR2 is equal to 1 plus 1, that is equal to NCR3, that is equal to 2. It is satisfied. For first value, this is the first set of value, 0, 2, 1. Kindly check up for second set. In the same, n is equal to 2. Second set of R1, R2, R3 will be 2, 0, 1. You have to understand the language also. I am calling it as a set of numbers satisfying the previous equation. NCR1 plus NCR2 is equal to NCR3. Now, this set, whether they satisfy or not. What is NCR1? 2C2. NCR2, this is equal to 1. NCR2 is equal to 2C0, that is equal to 1. NCR3 is equal to 2C1, that is equal to 2. That means NCR1 plus NCR2 is equal to NCR3. Satisfied. This is also okay. That means both the combinations for n is equal to, the answer is okay. Now, what are the combinations for n is equal to 5? That can be combinations of R1, R2, R3 will be let us check. Now, from the now let us do this. Afterwards, I will explain you. R1 is equal to 1, R2 is equal to 4, and R3 is equal to 2. Let us try this. Just we put a trial. NCR1, that is equal to 5CR1. 5CR1 is equal to 5C1. That is equal to factorial 5 by factorial 4 into factorial 1, that is equal to 5. 5C4 is equal to, that is also 5. 5C2 is equal to 5 into 4 divided by 2 into 1, that is 10. That means NCR1 plus NCR2 is equal to NCR3, satisfied. Now, there should be a general pattern. Let us try to understand it. Here, can we write? Let us try to generalize. Can we write n is equal to 3k minus 1 for k is equal to 1 to their values? Three into 33 up to 33. K is equal to 1 to 33. Can we get the same values? For example, k is equal to 2, 6 minus 1, 5. K is equal to 3, 9 minus 1, 8. These are all the numbers which satisfy this equation. This can be written as this equation, arithmetic, n is equal to 3k minus 1. Kindly cross check. I am writing it, but however you cross check. You do mathematics on your own. For example, to get 20, n is equal to 7. 7 into k is equal to 7. 7 into 3, 21. 21 minus 1, 20. K is equal to 1, 2, 3, 4, 5. Let us say 5. K is equal to 1, you get 2. K is equal to 2, you get 5. K is equal to 3. K is equal to 4. K is equal to 5. K is equal to 6. 6 into 3, 18 minus 1, 17. 33. That means this equation is okay. N is equal to 3k minus 1. From arithmetic progression, we get N is equal to 3k minus 1, where k is equal to from 1 to 33 for the given series. When N is equal to 3k minus 1, we get all the N values. Once we have got the N values, can we get some triplets? Let's have an idea about triplets. Do you know what is triplet? Can we get some combination of three numbers following a particular sequence? Here, when N is equal to 2, what are the R1, R2, R3 values? 0 to 1. 0 to 1, how can we write? For N is equal to 1, N is equal to, K is equal to 1, 3k minus 1, and N is equal to 2. Then, what are the values we have got? R1 is 0 to 1, like that. Can we apply triplets? K, this is okay. When k is equal to 1, k is equal to 1, N is equal to 2, R1 is equal to, the R's are 0 to 1. R's are set of 0 to 1. We are just trying to establish, will there be any relation? When k is equal to 2, N is equal to 5. Okay, this is valid. What is the combinations we have? 1, 4, 2. That means can we find some amount of a relation between them? Try to find. Take it as a homework. Try to find it. That means when N is equal to 3k minus 1, when we have found out, can we get for the set of R1, R2, R3 in terms of k as a triplets? Is it possible? Triples, is it possible? Can we develop an equation? Just see for it. It's only my intuition. For the problem, it's not required, but however, it's my intuition. The number of solutions. Now, you may have many number of numbers R1, R2, R3 for same number of n. For example, n is equal to 5. 1 is 142, we have found. Can we find any other number? N is equal to 5. Is there any other number for R1, R2, R3? R1, R2, R3. What are the numbers we have checked? 142. 142 we have checked and found. Okay. Now, can we check 143? What happens? N is equal to 5, R1 is equal to 1, R2 is equal to 4, and can R3 be 3? Does it satisfy NC R1 plus NC R2 is equal to NC R3? Is it satisfied? NC R1 is 5C1 plus 5C2. 5C1 and 5C2 already we have calculated. Not 5C2, it is 5C4. R2 is 4. These we have already calculated. 5C1, 5 plus 5, that is equal to 10. And what is the value of 5C3? We have calculated 5C2. Now we will calculate 5C3. Factorial 5 by factorial 5 minus 3 factorial 3. That is equal to 5 into 4 divided by 2. 20 by 2 is 10. That means left hand side is right hand side. That means even for, just to see, n is equal to 5, the set of r's is equal to 1, 4, 3. Another set also 1, 4, 2. It is satisfying. And like that, how many sets when n is equal to 5 are there? Permutations and combinations is a type of mathematics where we have to apply more logic than mathematics. Now n is equal to 5 is over. Now n is equal to 8. Let us take combination set of R as 2, 6, 3. This is set. N is equal to 8. Then 8C2 plus 8C6. That is how much? 8C2 is 8 into 7 divided by 2 plus 8 into 7 divided by 2, 28 plus 28, 56. What is 8C3? That is equal to 8 into 7 into 6 divided by 6. That is equal to 8 into 7 into 6 divided by factorial 8 minus 3 factorial 3. Factorial 3 is 6. 8C3 263. Let us write again. Full form. Factorial 8 divided by 8 minus 3 factorial and factorial 3. That is equal to factorial 8 divided by factorial 5 into factorial 3. That is equal to 8 into 7 into 6. divided by 6, that is 8 into 7, which implies NCR1 plus NCR2 is not equal to, oh, it is 56 by 2. Sorry, I made a wrong. This total is 56. Yeah, I thought individually it is 56. It's equal to, sorry, here it is equal to NC3. That means this combination is satisfied. Then you try another combination, n is equal to 8, r is equal to 2, 6, 5. Try to find out. Similarly, find all the combinations for n is equal to 5, n is equal to 8. Like this, the total number of combinations will be there which satisfy the above equation. They are limited because we are taking up to n is less than or equal to 100, where the last number is equal to n is equal to 98, which satisfies the equation n equivalent to 2 mod 3. This is one equation being satisfied. Another equation being satisfied is NCR1 plus NCR2 is equal to NCR3. You will get different number of combinations here. Why I have taken this up to n is equal to 100, I will tell you. When you practice more and more long problems, if it is given as n is equal to 10 in the examination, find the combinations of R1, R2, R3 for which this equation is satisfied. You can easily find out the numbers R1, R2, R3, the number of combinations. This is how a question can be asked in the Maths Olympiad or JEE Advanced or any higher level mathematics. With this, I want to stop this class. You might have understood. The homework is very clear. I have done for n is equal to 2, n is equal to 5 and n is equal to 8 partially. You complete for n is equal to up to 100. Whatever the possible combinations are there, write all the combinations, check up for R1, R2, R3 values, then cross check whether NCR1 plus NCR2 is equal to NCR3. Then you satisfy yourself that that particular equation is satisfied, and also the congruence n equivalent to 2 mod 3 is satisfied. Then you will get the total number of combinations and total number of n values, and sum of the n values also you will get. This is how a problem to be solved. Don't worry for the answer. Try to understand the procedure and clear your concepts. If this type of question comes in your examination, please do it with full confidence by understanding the concepts clearly and applying them. Best of luck to all of you. Best of luck for listening to me. Best of luck. Thank you for listening to me. Best of luck to all of you. Thank you for viewing my lecture. If there is a value addition to you because of this lecture, kindly share my videos and subscribe to my channel Maths and Science by IITian. I will be bringing more and more lectures of this type to you in future on permutations and combinations. Thank you.